going to be covering over all the main economic topics, all the math topics you need for economics. There's a lot of stuff we're not going to cover. We're just going to cover the main types of math you need to know, which is simple arithmetic and maybe a little bit of algebra. So the main type of opportunity cost you learn how to calculate is this type of comparative opportunity cost, where you have a chart and you try to find the opportunity cost of one product or another, or possibly a PPC graph. But what people forget about is the per unit opportunity cost. Per unit opportunity cost is a simpler type of opportunity cost. It's simply the opportunity cost of a total amount of goods. So let's say it costs $100 to produce 5 hoodies. Well, it's simply opportunity cost, so in this case 100 divided by the 5 hoodies, and we get the per unit opportunity cost is 20. So that's per unit opportunity cost, different from the normal type of opportunity cost we have. Then you need to understand, ignore all of this. Now we need to understand implicit and explicit costs. Implicit costs are simply opportunity costs. That's all it is. Explicit costs are direct out-of-pocket costs. So let's say it costs $1,000 for rent, to rent a business. Then that's an explicit cost. Let's say it costs $3,000 for refrigeration or electricity. That's explicit cost. So remember the difference. Then I've seen a lot of people get tripped up about this. Revenue is the total amount of money a business makes. Profit is revenue minus costs. So it's simply the amount of total money a business owner or a business is actually making. So revenue is total money. Profit is simply money after expenses. And we have two main types of profits. Accounting profit, and this is where a lot of people make a mistake. Accounting profit is total revenue minus explicit costs. So this one is just out-of-pocket explicit. Only explicit. So remember E. Economic profit is both. So remember, economic profit is total revenue minus both costs, explicit and implicit. Accounting profit is just explicit cost. Just remember all of that. Now let's learn how to do actual opportunity cost. This was per unit. Let's learn the actual opportunity cost. So here we have a table of 2 different products in 2 different countries. Cars, jetpacks, and then a country A and B. So how do we calculate it? Well, let's say we're trying to find opportunity cost for country A to produce a car. It's simply the other product they produce divided by the main product. So here, to find the opportunity cost of cars, we take 1,000 jetpacks and divide it by 1,000 cars. Then we get 1. Let's say we switch the roles. Let's say we're trying to find an opportunity cost for 1 jetpack for country A. Same thing, 1,000 divided by 1,000. So 1,000 cars divided by 1,000 jetpacks, and we get 1. Now let's do a little bit harder. Let's try to find opportunity cost for country B. What would that be? Well, for cars, 2,000. Let's try to find opportunity cost for cars. Well, it's the same thing. You take the other product, so 4,000, and then you divide it by the amount of cars, 2,000, and then we get 2. So the opportunity cost here is 2. Let's say we switch it up now. Let's say we're trying to find an opportunity cost for jetpack, that one individual jetpack. Same exact thing, we flip it though. We do cars, so the other product, divided by jetpacks, so 2,000 divided by 4,000, and we get 0.5. Now there's another and simply easier way to calculate all of this, and it's called the quick and dirty method. Here, you just multiply the diagonals. So let's do that. Multiply these 2, and we get 4 million. Multiply these 2, and we get 2 million. 4 million is bigger than 2 million. So these 2 are our comparative advantages. So the quick and dirty method, you multiply the 2 diagonals, the larger number is your comparative advantage. So that means country A has a comparative advantage in cars, country B has a comparative advantage in jetpacks. Now we need to understand utility maximizing. Utility is simply the amount of benefit you get from a specific good. So if I eat a burger, then I get 5 utility. But there's also the law of diminishing marginal utility. The more you consume of a product, the additional satisfaction generally decreases. So, for instance, let's say I eat one piece of cake, then the util will be 10. But if I just keep eating and eating cake, 10, 20, 30 slices of cake, it's going to cause me some health issues. I'm not going to have the same amount of satisfaction. So that's the law of diminishing marginal utility. It slowly starts to decrease. Utility maximizing is simply maximizing the amount of utility you make per your dollar. And there's a complex formula, but you don't really need to know the formula. Just need to know how you can do this. So let's say, first of all, that we have $10. Actually, let's say we have $8. What should we buy? Well, here, apples are $8 and bananas are $4. So, what's better? One apple that we can buy for $8, that's all our money for 10 utils, or we can buy one banana for 4, then we can buy another banana for 4. So in total, we would get 12 utils. So that's our best utility maximizing. If we have $8, it is best for us to buy 2 bananas because we get 12 utils compared to 10. Now let's say we have a bit more money. Let's say we have $12. So $12. What do we do now? Well, it's still better. It's still good to buy one banana. But now we have $8 remaining. With the $8 remaining, do we buy 2 more bananas? We get 7 utils. Or 1 apple, and we get 10 utils. It's better to buy 1 apple. So with $12, we buy 1 apple and 1 banana to maximize our utility. So that's utility maximizing. You're basically finding out the different combinations that maximize your utility. Now we need to understand elasticity. Elasticity is simply basically the slope of a demand or supply curve. These are our different types of elasticity. Perfectly inelastic has a coefficient of 0. A relatively inelastic is less than 1. Unit elastic, what we normally deal with, is 1. Relatively elastic is greater than 1, and then this reaches infinity. So the general formula here is that change in price, you don't need to understand this, just remember change in price, change in quantity demanded over change in price. That's our general demand elasticity formula. For supply, same exact thing, percent change in demand versus divided by percent change in price. So let's practice. If the price elasticity of supply for pickles is 2, then the price increased by 10, then the quantity supplied of pickles increases by. For these types of questions, just break it down. Break it based on the formula. So our supply elasticity is 2, so we already have that. And then it's divided by the percent change in quantity demanded, which is what we're trying to find here. So this is what we're trying to find. So instead of writing percent change in quantity supplied, I'm just going to write X because that's what we're trying to solve here. And it increased by 10%. So the price increased by 10%, so that's our denominator here. That's the formula. So instead of writing 10%, I'm going to write 0.1 because that's just simply easier for me to write because, I'm more used to 0.1 than 10%. For these types of questions, always convert the percents to decimals. So this is just a simple math problem. Multiply both sides by 10 to isolate the x. We get 20 equals to x. So the actual solution here is E, 20%. Then we have different types of elasticity. Here's cross-price elasticity. It shows how sensitive a product is to a change in price of another product, and it can show if a product is substitutes or complements. The general formula is a percent change in quantity demanded of A over the percent change in price of B. So you're taking two different goods. Then we have income elasticity. Same exact thing, but this time it measures it tries to measure if a good is a normal good or an inferior good. So let's practice. If a 10% increase in the price of good X results in a 20% decrease in the quantity of good Y, which of the following is true? Well, let's just go back to our formula. Percent change in quantity demanded divided by percent change in price. So what's the change in quantity demanded? It's a 20% decrease. So negative 0.2, that's our 20%, and then a decrease means it's negative. Then 10% increase in price. Increase is positive, so we're going to do positive. That's our general formula. Remember, percent change in quantity demanded over percent change in price. This is percent change in quantity demanded, 20%, and then this is our percent change in price, 10%. What we get here is negative 2. Remember, negative is complementary, and then negative 2, so our answer here is C. Now, this is just simply, I've seen this occasionally. Sometimes they ask you how to calculate consumer, producer surplus, or even deadweight loss. Just remember, most of the time it's a triangle. You use 1/2 base times height. That's how we calculate the area of a triangle. Sometimes they ask you it and it's a rectangle or a circle, not a rectangle, a circle, but it's a rectangle or a square. Those are simple. You just multiply the two side lengths. Now we have different types of costs that we learn about. A fixed cost is simply costs that don't change. Things like rent, electricity, things that generally don't change. Variable costs do change. Those could be wages. Those could be labor costs, things that actually change. Then total cost is simply adding these two types of costs. Then average fixed cost, you take the fixed cost and you divide it by the quantity. Average variable cost divided by the quantity, and then average total cost is total cost divided by quantity. Then the marginal cost is almost like the slope. If you take in calculus, it's like the derivative. It's just the additional cost for every quantity. So let's actually practice here. Assume that the fixed cost is $50. Based on the cost and output data in the table above, what is the marginal cost when the firm increases its output from 3 to 4 and the average total cost of producing 4 units? So let's look. What is the marginal cost when the firm increases its output from 3 to 4? So how do we find marginal cost? It's simply the additional cost. So what do we find? 90 minus 65, that's equal to 25. So the marginal cost is 25. So let's look at these answer choices. It's not A. It's not B. It could be C. It could be D. It's not E. So let's find the average total cost. Fixed cost is 50. Then you add that with the variable cost. Remember the formula. Total cost is fixed cost plus variable cost. So $50 plus the variable cost, 90, 140. Then divided by the quantity, which is 4. 140 divided by 4, and you get 35. So C is our correct answer. Now, that's definitely not all the math in AP Microeconomics. There's a lot more, but those are the basic types of math questions you need to know. There's some simple formulas you need to know. Always remember the quick and dirty method. It's much quicker. Utility maximizing confuses people. Just need to know the different types of combinations almost. Elasticity is a really tricky topic for a lot of people. Just remember percent change in quantity demanded over percent change in price. Convert the percent, so if you get 10%, convert it to decimal and set up a formula like you might do in a math class. Always remember these types of formulas, and then don't get confused on this. The costs are pretty simple, and then you're mostly fine. You can understand almost all the math concepts in AP Microeconomics.